Hello all again. Welcome back. This is my second video now. I'm actually going to go through the second question in the May 2020, which is quite a difficult question. It's actually a 5-mark back titration question. As you can see, I'll be using the latest paper for this, and I'm going to be doing, I've actually done question 1 in a separate video, okay? I'm actually going to do one more video. I'm actually going to take this to question 2 now. So you can see here, this question is about titration. A student dissolves an unknown mass of sodium hydroxide in water to make 200 centimeter cube of aqueous solution. A 25 centimeter cube sample of solution is placed in a conical flask and is titrated with the sulfuric acid. You can see the question there, okay? You can see the equation. I would suggest maybe write down the equation because I will be using that. And also, this is the table of results that I'll be using as well for the question. I will come in and out while I do the solution. So you will see this page again. And I'm going to be calculating the mass of the sodium hydroxide. Okay, so what I'm going to do now is I'm actually going to take it away. I'm actually going to go to my written screen. So I'm going to give you the work solution for this particular question. Right, so hopefully you can see my screen, okay? So what's actually going to happen now is I'm actually going to go back and I'm actually going to go through the actual exam question and just work through the solution for that one. So it says here, like, it says a student dissolves an unknown mass of sodium hydroxide. So you've got X, which we know is unknown sodium hydroxide, and we've got X grams because it's actually an unknown mass. And it's dissolved in water and made to a 200 centimeter cube solution. So this is actually coming under your core practical number 1, where you're making a standard solution. And generally, when you do make a standard solution, we use an apparatus called a volumetric flask. Okay, we use a volumetric flask. And in this question, it says a student dissolves an unknown sample of sodium hydroxide to make 200 centimeters cubed of the solution. So we also know now that in terms of the volume that we have here, is we have 250 centimeters cubed because we put the mass in there and we've added distilled water until it reached that 250. Now we are actually saying, it says 25 centimeters cubed of the sodium hydroxide solution was placed in a conical flask and is titrated with 0.15 moles per decimeter cubed sulfuric acid. So what you're actually doing is you're actually taking out 25 centimeters cubed of the sodium hydroxide. And then once you are taking that out, you are then titrating it. You are then titrating with sulfuric acid, H2SO4, and you've got a concentration of 0.150 moles per decimeters cubed. And what you are asked to do, you've been given some titration values and you've been asked to work out the mass of the original solution. So what I'm actually going to do is you can just take a quick look at that. So you've got X max of sodium hydroxide dissolved in 200 centimeters cubed. Okay, and then 25 centimeters cubed was taken out and then titrated with sodium hydroxide. And you can actually clearly see this would actually come back and it would actually show you what's actually going on in the case of this question there. So you can actually see, yes, you've got the unknown sample dissolved in 200, okay, inside the volumetric flask, as I've shown you. 25 centimeters cubed of the sodium hydroxide is taken out and it's actually reacted with the sulfuric acid. So I'm actually now going to just take a look at that, and I'm actually going to just say, okay, we know in terms of what we have. So we know in terms of sodium hydroxide, we know we have that fixed volume of 25 centimeters cubed that was actually taken out. We also know in the case of sulfuric acid, right? We also know in the case of that, we also know that we have a concentration of 0.150 moles per decimeters cubed. So we know we have that concentration. But what we can also do is we can actually use this table to actually get a volume. So we've got the final reading, initial reading, and we've got the titers. Right, we've actually got a rough one. We've got 1, 2, 3. Just remember, you never use a rough one. Okay, you always need to use the ones that are within range of each other. So if you look at that, and that, which is 19.55. Sorry, get rid of that one there. So if you use that one and that one, and you will not use the other two. So when you're actually working out the average titra, make sure you use two values only within, let's just say 0.1 centimeters cubed accuracy. So you can see here that you've got 19.6 to 19.55. They're within the 0.1. It's actually 0.05. So it's actually even better. So for that particular one, if I was to work out the average, I would have simply have done 19.60 plus the 19.55, okay, and that one then divided by 2. So I would have done something like that. But I'm going to do the main calculation back on my piece of paper. It's a lot easier, but hopefully you can see that. Right, I'm now going to go back to my piece of paper, and I'm now going to carry on with actually answering the actual question. So we also know now that we actually have a titra, so we're actually going to use the two titras, like I said. So we're going to use the 19.60 plus the 19.55, and we're going to divide it by 2. So we've got the actual titra that we're actually going to have for the sulfuric acid is 19.575 centimeters cubed. Okay, so that is what we have so far. And again, remember the question, we actually need to work out X, which is the mass. We've been given a reaction. Okay, we've been given an equation as well to work from. Okay, the equation that we've been given to work from, okay, is actually going to be 2 moles of sodium hydroxide, plus the sulfuric acid, and that's going to give you your sodium sulfate, Na2SO4, plus your H2O, or 2 moles of H2O, and that was given inside the question. And we also know we have 25 centimeters cubed of that. We have 0.150 moles per decimeters cubed of that, and we also have 19.57 centimeters cubed of that. And we've been asked to work out the mass of the original, and really be careful because that X was dissolved in 200, not in 25. Really be careful of that. I'll come to that in 1 second. And just one other point as well is that if you're actually going to calculate the mass of something, you would actually need to do MR times the mole. Okay, we can use the periodic table to get the MR of sodium hydroxide, which is 23 plus 16 plus 1, using the mass numbers. So that's actually 40 times the mole. So technically, if we are able to get the moles of the sodium hydroxide that will be dissolved in 200, we can pretty much answer that question. So let's get the moles. Let's start by getting the moles of something. So if we look at this calculation here now, okay, if we actually do look at a calculation, we can actually see now we can actually work out the moles. We can actually work out the moles of the sulfuric acid. And the moles of the sulfuric acid is going to be concentration times volume over 1,000 to calculate the moles. So that's going to be 0.150 times up by 19.57 over 1,000. The reason why I divide by 1,000 to convert that into decimeters cubed. Okay, so if I did that inside my calculator, I'm going to have 0.150 times up by 19.57 divided by 1,000. Okay, so I'm going to have 0.150 times up by 19.57 divided by 1,000. I'm going to get that to be 0.002935. That's the moles of sulfuric acid, but we need to be working sodium hydroxide. So what's the best thing to do? Okay, let's come back here. Let's come back to the equation here. And what we can actually do is we can use the molar ratio. We've got the moles of that, molar ratio is 1 to 2. So if we took that value and we times it by 2, we can actually get the moles of sodium hydroxide. Okay, but remember, one thing to remember, in 25 centimeters cubed. That's very important, but that's because that's how much volume that we have. Okay, we actually can divide it by, times it by 2. So 0.002935 times that by 2. So if we multiply it by 2, we get 0.005871. That's the moles of sodium hydroxide in 25. But remember, it was actually dissolved in 200. So if the moles in that 25, if the moles in that 25 was actually 0.005871 as we calculated here, then all that we have to do is we have to go from there to there. So we actually need to times it by 8, because 25 times 8 is 200. So therefore, if we got that 0.005871 and times it by 8, the moles that we have there is then going to be 0.046968 moles. And that's the moles which was dissolved in 200. So can you see the ratio? As the volume changes, so does the number of moles, because when you go to a larger moles, there's more particles. That's what moles means, amount of substance or number of particles. So there obviously there's going to be more particles in 200 compared to the 25. That's the reason why there's a increase, and it's an increase by a factor of 8 as the volume increases by a factor of 8 as well. Okay, so just coming back down here, okay, we now know, just coming back down there, we now know that the moles of sodium hydroxide in now 250 centimeters cubed, there's now times by 8, okay, that's now equal to, so I'm going to go there, times it by 8. Okay, so if I do times that by 8, I'm actually going to get a value here. Okay, I'm actually going to get a value there, as we worked out before, 0.046968. That's the moles of sodium hydroxide in 250. Now just complete the question. So mass is equal to mR times the mole. So that's exactly what we went to at the start. So now we have the moles, which is going to be that moles. mR was 40. Okay, so we do 40. Times that by 0.046968, and then the final answer 1.8988 grams. Okay, thank you for listening. Like I said, if you need any help or need a private online tutor, okay, I'm based in London as well. I also do home tuitioning and stuff like that as well. Please see the details below, and I'll also put a link to the notes as well. And I've actually done a previous video for the first question, but I'll be releasing little videos as the time goes on. So hopefully you've had a chance to take a look, and hopefully you have understood what was actually going on there. So thank you for listening. Take care.